starting, that's all, right? All right, so the picture that you see there has nothing to do with the chapter. I just like to put fun pictures on there. If you get bored, you finish your assignments or notes early, whatever, you can doodle on there, you can color on it, whatever you want, right? And that's what that is. So nothing connected to our notes. Our chapter today, or this for the next month and a half, 2 months, are exponents. Right? So in grade 8, you got introduced to what an exponent is. I'll check if you're going to remember what that is in a moment. Right? Exponents is a somewhat large idea in math, and in grade 9, we introduced just the basic ideas of how to do some calculations with exponents. Right? If you were to graph an exponent, the graph for an exponent looks something like this. So if I have a graph like this, the graph would grow like this. In grade 9, you don't graph exponents. It'll be like a curve that kind of shoots off into space like that. Or maybe it comes down like this. And lots of things naturally like, for example, population growth, virus growth, bacteria growth, they have curves like this. Right? So later on, we'll do a couple of application questions that involve it. But later on, in future years, you'll get more into detail of applications of exponents. But this year, we're just learning what exponents are and how to do some basic calculations. That's it. Right? So let's start off with, because some of you guys leave things behind in the classroom, let's write your name here and your block. Whatever your name is, with your block, we are block B. All right. Okay. So now, some of you guys like to learn by listening, and I'm one of those people too. But you gotta listen, and you also gotta write. So, right. So when we're taking notes, please write, and this is gonna help you later on, because we have a final exam we are going to do at the end of the year. And at the end of the year, by the end of the year, we're going to build something like this. This is a little note sheet, that summary note sheet that you get to bring into the final exam. Right? So you base all the stuff off of here, off of your notes, off of your assignments, and stuff like that. Right? So a lot of times students are, I'm glad that they're listening to, Mr. Dhaliwal, this makes sense, I get it. But by the time May rolls around, you start forgetting, you don't remember. Even though you did understand it back in September and October, and most students do very, very well in this first chapter, right? So please just don't listen, also write, because you're going to need these things to refer back to, all right? So I know not everybody has a good habit of writing notes down, right? So this, if we flip the page over, we got something like this. This we're not going to do today. This is a summary of everything we're going to learn in this chapter. We'll touch on that at the end of the year, end of the chapter. Right? So we're going to flip over and we're going to start right here. So my notes are usually 1 to 2 pages long, every set of notes. Right? It doesn't mean we'll do it all in one sitting. Today we're not going to get past the first page, right? But you'll see it'll say something like day 1. That's my first set of notes. It may actually take me more than 1 day to do these notes, right? That's just my first set of notes. Then it'll say, flip it over, it'll go day 2, day 3, day 4. And the assignment book that I'm going to give you next day matches this. It'll say, this is my day 1 assignment, this is my day 2 assignment. So you kind of, everything sort of just line up, right? Right, so we're going to do our first set of notes. Right? And last year, you saw something that looked like this. That's how I draw my sevens. A little line through there. As you get into higher grades, maybe your teacher told you that a little bit more often. You don't want your sevens to look like ones and stuff like that, so I always draw a little line through there so my sevens don't get confused with ones. Right? Okay, so 7 with a little 3 floating up in the air. What does that mean? What do you remember from last year? Maddie?
7 times 7 times 7.
Yeah. It says, hey, this top number says repeat this 3 times over. Okay? So that's all that means. It means this calculation. Right? This number tells you how many times to repeat the other one. Okay? And last year, your teacher probably was happy if you knew that and you can grab your calculator, you can get the answer. Right? We're sort of getting to a little bit more detail, a little more vocabulary as well. So this here is called a repeated multiplication. Right? So if I tell you, hey, here's this expression, what is its repeated multiplication? That's what I want you to do. Right? So you got to know these words. Because often students get stuck when they're doing assignments and tests, not because they don't know the math, they don't know the words. Right? That means repeated multiplication. But there's another word I could say. I could also say, write it in expanded form. It means the same thing. This is condensed. This is expanded form. So, easy question, isn't it? Here's this thing. Write the repeated multiplication, or write it repeated, or as expanded form. That's all I'm asking for. Okay? You got to know those words. Like I was saying the other day, I do lots of quizzes. One of the quiz questions will be next week when you see me on, I see you guys on Tuesday and Thursday. Probably on Thursday. Be, hey, can you write this as a repeated multiplication? That's all you have to do. Easy mark. Another question will be, hey, can you name the things here? There's lots of numbers here. The numbers have names. Let's see what you feel know. We have a 7. Let's color that in orange. And we have that purple 3 floating up in the air. Does anybody know the names of either of those numbers? In this expression, those things have a name. I don't know. Does anybody know what it might be? Ernest, you want to take a guess? Huh? Oh, I thought you were raising your hand. No? Hayden?
Oh, 7 is the base.
7 is the base. Yeah, so the 7, the big number at the bottom, this is called the base. Okay? So, this expression consists of a base and the number floating up in the air. The number floating up in the air. Anyone want to take a guess what that might be called? Maddie? Exponent. Exponent. Okay. All right. So there's 2 parts. We have a base and we have an exponent. So I'll have a question next day. I'll say, here's this expression. What's the base? What's the exponent? It's not hard. You just need to know what those words are. There is another word that most people get wrong. And it's just because, you know the way I grew up, the math teachers didn't use this word right. And some of you guys may know this word power, right? The word power gets used with exponents as well. And it often gets used incorrectly. The people will say the phrase 7 to the power of 3. And then people in their mind think the word power and exponent means the same thing, and it doesn't. And then there's just an error over the years, and nobody really corrected, right? When you use the phrase power, the word power means this whole expression is called a power. This whole thing is a power. So if I ask you for an exponent, you're going to tell me it's a 3. If I ask you for what's the base, you're going to tell me it's a 7. If I ask you for what's the power, you're going to write the whole thing down, right? So think of power as the calculation. If I tell you to find the sum of 2 and 3, that means sum means add these things up and give you the answer, right? If I tell you to multiply or the product of 2 and 3, you go 2 times 3, right? So the word power means this calculation or this expression, right? All right, so let's put this to work. Is that okay? There's 3 words. You just got to know it. Quiz question next week. What are these 3 words? All right, so I've got this thing sitting here. So here's the 3 words. Anyone want to guess? What's the base? What's the power? What's the exponent? Take a guess at any one of those if you think you might know. George?
3 is the base.
3 is the base. Now, 3 is the big number, but there's other things floating here, George. Is it just 3 or what do you think?
No, it's also the negative.
It's also the negative, right? Now, I haven't talked about negatives and that kind of stuff, right? So negatives and exponents are kind of tricky. So for now, just take my word for it. Let's just put the -3 in brackets, everything on the bottom there, all right? And I'll talk more about negatives in brackets. Probably not today, next call, right? All right, so the thing in the bottom, all right? So we have 2 things left over. We have an exponent and we have a power left over. What's what? John?
The exponent is 5.
Exponent is 5. Take this thing here, and it's the 5. Maddie?
The power is negative 3 exponent 5.
Yeah, the whole thing. That's it. Right? None of this is very hard. You need to know the words and have it written down, because when June rolls around, you're going to forget what is the base, and you're going to forget what the exponent is. It's not hard, it's just something you're going to forget. That's the gift of Father Time. Forgetfulness, right? All right, so not too bad. Okay, so now let's do some work with this. All right, if I give you this thing here, remember that's called a repeated multiplication. I want you to go backwards. I want you to write it in exponential form, which means write it as a power. So those 2 words mean the same thing. So if I want you to write a power, I need a base and I need an exponent. Right? That's a power, also known as exponential form. Looking at this multiplication, what should the base be? What should the exponent be? Maddie?
The base should be 4, the exponent. Or no, the base should be 3, the exponent should be 4.
So 3 and 4 like this. Do you guys agree with Maddie? Disagree?
I agree.
Agree? Yeah. Maddie got it right. That's right. That's it. Right? Not a hard question. Right? But if you don't know what the words are, you're not going to right. Okay, now if I ask you to evaluate the power, what am I asking you to do? Answer it. So we grab out our calculator and we go 3 times 3 times 3 times 3, and we come up with the answer. And some of you guys might be able to do this in your head. 3 times 3 times 3 times 3. What is that answer? Peyton?
12.
Not 12. Carter?
81.
81.
Oh.
Yeah, that's a very common mistake. All right? If it was 3 plus, then it would have been 12, right? So, if you grab your calculator and you went 3 times 3 times 3 times 3 times 3, you would have got 81. Now, I could have easily changed this question to 3 with an exponent 15. All right, then you're going 3 times 3 times 15 times over your calculator. Your likelihood of making a mistake goes way up. Maybe you don't put too many 3's in, not enough 3's in, right? Your calculator has an exponent button. So we're going to learn how to use your calculator and the exponent button. Now, depending on the calculator that you bought, the exponent button looks different. Who's got a calculator here? If you do, grab it out and I'll show you and I'll help you to get your calculator. Right? So if you don't have it, remember you need to get a scientific calculator for next week.
No, it's in my locker.
It's kind of weird. You're here, but your locker is over there.
Wait, you mean it's a scientific calculator right now?
Yeah.
I have a calculator.
Okay. So have a look at your calculator. Somewhere in the middle portion over here, you're going to look for a button. And there's like 4 or 5 different ways this button looks like. For me, the button looks like this. An upside down V. That's called a caret. you may have a button that looks like that. Some calculators don't use that button. They use a button that says Y with a little X floating up in the air. Or some calculators have X with a little Y floating up in the air. Or sometimes they like to use the letters A and B. Or maybe an X with a little empty box like this. So this is not standardized, right? There's lots of different, depending on the calculator you have, there's lots of different ways it can look like, right? So if you don't have one, please by next week, get one, all right? So I'm gonna grab my calculator. It goes like this. I go 3, I hit my exponent button, then I hit 4, and I press equals, and I get my answer. All right, so I'm gonna come around, I'm gonna help you guys to use your calculators, right? Make sure you know how to do it. All right, so please get in a habit of bringing a calculator every single day. You are going to need it. And like I said, hey, this button looks different on each calculator. So borrowing one from me or borrowing one from a friend is not really helpful because they all have a button that looks different than yours and you'll be lost. You don't know what button to push. So get your own calculator, you get comfortable using it. I suggest getting the one I clicked on Amazon or Staples. Those ones will give you less grief. All right, so not too much more. I'm probably going to talk about 2 more questions and we'll call it a day. All right, so if I ask you to evaluate this, practice with your calculator. If you don't have a calculator, do it in your head. Is the answer 8? No. 16. Remember, this means 4 times 4. Not 4 times 2, which is 16. Okay. So before we go on to the next one, right? Last year, you guys worked with shapes. You should have worked with shapes. And you did calculations with area and volume. Does anybody remember how to calculate the area of a square? Yes, Sean?
You look at the outside boxes and you count those and you multiply it with the constant.
Yeah. So area is like you're multiplying the two outsides together. We had a formula that says length times width. So it would have been 4 times 4, right? And we would get 16, right? And let's on the shape here, I'm gonna say 4 centimeters here and 4 centimeters here, like this, right? And I said, if I was your teacher, and I'm hoping your last year's teacher said, hey, you can't just give me a number, you should have units as well, and the units for area always looked a certain way. What if I said that's 4 centimeters this way and 4 centimeters that way? What should the units for this be? 16 what? Not just centimeters. Centimeters squared. Right? Now that you're doing your exponents unit, you can understand why this is centimeters squared. What we have here is 4 centimeters times 4 centimeters. What do we have? Centimeters repeating twice with an exponent 2 because it's repeated twice. That's why area was always centimeters squared, meters squared, feet squared, because it was always the same thing repeated twice. So the base stays the same, it's repeated twice. That's where the 2 came from. Right? And I like the fact that you said squared. So we could say 4 exponent 2 here, but the exponent 2 and the exponent 3 gets used a lot in math and science classes. So there is a shorthand of how we pronounce these things. So they're saying 4 exponent 2, we would say 4 squared. So that squared means exponent 2. Right? Like we said, centimeters squared means exponent 2. All right? So that's where all these things came from. Now, if we have the exponent 3, we don't say, we say 2 what? How do we say an exponent 3? You guys remember that one? Cubed. The shorthand for exponent 3 was cubed. So this is read as 2 cubed. Right? And where does it come from? The square comes from the area of the square. The cube comes from the volume of a cube. So when you do volume of a cube, I'm hoping you remember this from last year. It was length times width times height. Multiply all the sides together. It was 2 times 2 times 2. If you multiply 3 2's together, do you get 6?
No.
No. Hi. Good. You caught me. What should it be? 8. So this is 8. Right? And remember when we did volume, the units were always cubed. So this would be centimeter times centimeter times centimeter. So 3 centimeters. That's all it means. That's where it comes from. Right? So the units aren't mysterious. There's a reason behind it. That's why I, or your last week, leave that 2 there. Means something. Okay? And that's where we're going to stop. That's it. We got 10 minutes left. You can hang out. Right?